Let's do it, buddy. Hello. Let's start with our today's DSA journey with this amazing visualizer by dsa.chaicode.com. Use this link, this one. Okay. Now let's move to our today's question, which is this one. Remove the nth node from end. Okay. Remove the second node from end. Let's take it. So suppose we are given a linked list. Linked list, simple linked list. Now we have to remove the second node from the end, which is nothing but this 4. So simply remove. If we remove it, we can easily get this one. This is 5. 5. So this one, and we can see this one. We have to perform this one. But how? Let's do it in a 2 pass. Okay. So we can actually, so what we have to do is at the starting. Oh, let's take it, and now take the whole thing upper, remove this. Okay, so we have to remove 4 here. How could we remove 4 here? Just a simple thing, that first we calculate the length. So what is our length? 1 2 3 4 5. So 5 is our length. Okay, which element we have to remove? The second is 2, so n minus 2 plus 1. Remove this node. What is this? 5 minus 2 3, 3 plus 1 4. Remove the fourth node, same fourth node. But how? It is nothing but first we have to actually calculate the length of the linked list. What is our length? Our length. Then how, what is the element, like what element did you want to remove, which is second element, which is nothing but n plus 1. So we have to start from the starting and go till this index, which is 4 here, which is nothing but l minus n plus 1. What is l? L is the length. What is n? N is nothing but the element number, like the second element actually mentioned here. So, but how actually we can go to here, because we have to calculate the L here. So how could we calculate L? We simply go and run a whole loop, like the loop through the whole linked list, and we can easily get a link. We can easily get the size. Okay. Then simply return minus n and plus 1. As simple as that. This is our simple approach. Okay. So until we reach that, so 1 2 3 4 5 and not null. So we have to reach this 3, and after reaching this 3 we have to connect this pointer. As simple as that. Okay, now write the pseudocode. I will not code it like go to lead code or not. I will code the optimize approach, which is a few lines approach, which is very simple like that. So here we are given a head. Let's suppose L is nothing but length of linked list. L is nothing but length of the linked list. Okay, how could we calculate it? Take a pointer from the starting and traverse till the end. Okay, so this is our simple approach. And now simply go to our next calculate. So traverse till till second element or the second last element or anything as mentioned here. Remove the second node from the end, so it will give us 2 in end. It is given to us actually. So we traverse till that position and then simply do this thing. Current next is equal to current next. Simple. So it just point, this loop just point, we are at 3, next and next, just point towards that, as simple as that. And at the end simply return head. So return our head. This is our simple approach. Okay, yeah, I made a mistake. I made a mistake, a very big mistake. Can you spot? So we got the 4 here and our pointer reaches to here. And we have to go to the previous pointer, which is nothing but, not reevaluate. It works. Yeah. But you have to go until this point. So it simply means you have to perform operations like, if we say like the if you take a counter is simply equal to L minus N. Okay, let's don't focus this actually. I just show you the code. Give me a second, I just show you the code. Uh, so I think this one I solved. Yeah. First we go and check the length and then perform according to this one, like a length minus n minus 1. Why length minus n minus 1? Because we have to go to this index. As simple as that. Then just simply temp next index minus minus, then just put it. Easy code. Okay, we don't focus on that. We focus on the optimal approach, which is a very interesting approach. So we is previously actually we uses slow and fast pointers. Okay, so take our linked list like 1, 2, 3, 4, 5, 5 and null. Okay, well, otherwise let visualize it here. Actually it is more helpful actually here. So we take 2 pointers, so our gap is 2, so slow at 0 and fast as 2, so we just move 2 step, we just move 2 step ahead, just 2 step, we just actually moving 2 step and nothing else, because we are given in as 2 actually, we given a in here, simple. Now loop it until we reaches the last. Actually now we reaches the last point. Now see where is our slow and where is our fast. Just as see that our slow and fast, our slow at 3, our fast as at 5, and in between them there is only 4, and we have to remove that element only. Just put a pointer here, as simple as that. This is super simple. If you go to practice and just I just write to the pseudocode given and keep 2 pointers exactly in distance gap. Okay, exactly in distance gap, and while our first pointer, which is ahead pointer, is at the last index. it is at the last index. Okay, until reaches the last index, simply increase the slow pointer and the fast pointer. Is the slow pointer and the fast pointer until it reaches. So if you see here, like until it reaches the end, we just take pointer and we increasing it. The fast reaches the end, it simply means we are actually in the gap. We are actually in a gap. Always we are in a gap. And and after reaching that, we have to make sure slow uh, slow next is equal to slow next and simply return head. You may question why slow next? Why not fast? Because what if the gap is 3? There should be like a 6 here. The slow at 3, the another point is 6 at say fast as 6. So there is two points in between them. Okay, so we have to remove only one, and which is nothing but the next pointer of slow. Here I just yes. Let's run it and check it. Okay, do it, or let's go and it is a good answer. To be very honest, it is a okay answer. It is actually the approach we have to follow. So now let's run it. Run or write the code actually here, which is nothing but list node star. First we take a temporary node, a null node you can say. Simple new list node, type -1 0 anything you want. So let's point it, it's nothing but the head, as simple as that. Now take two pointer, one is slow pointing to the stem, okay, another one which is fast is nothing but pointing to temp also. Okay, now now take while n minus minus until we reach the point, simply do fast equal to fast next. Simply increase it, and nothing else. Just increase pointers. And now the simple condition, and I think I should do it reevaluate because this happens many times. So until the fast is not equal to null, or not fast not equal to null, the fast next is not equal to null, it simply shows that we have to move forward. So make the slow one step ahead, also make the fast step ahead. Okay. And we have reached our last. If we reach our last, simply do slow equal to, or rather slow next, not slow next, we have to change the pointer, slow next equal to slow next. Okay, and at the end simply return head. I think this should work, otherwise I will check it. There is a mismatch actually, but it shouldn't. uh Okay, let me check, let me give 1 minute. So actually what happens here, when we are actually there is a only one element. Okay, only one element. When we remove the first element, it should give us a empty, but the head is always pointing towards that one. So suppose it will give us like this one null. The head is pointing to this, and suppose this is our temp which is also null. Now condition. Okay, so we just simply break this loop, but we are returning this head. We are returning this head. Okay, see, we are returning this head. The head is also one, but we don't have temp next. The temp next. Why? Because now our current head is our temp next. For that reason, we are actually taking this temp. Okay, so at the end, simply return temp next. Now just run it and check it if it's work on its. So now temp next, which is also a null. Simple as that. Yes, we beat it. Okay, we beat everything, everyone. So it just simply big O of n. Don't store anything. Literally, we don't store anything. We don't store anything here, and we just traverse the linked list only one time. So big O of n is the time complexity, and big O of s is big O of 1 is the space complexity. I don't know why this gives, and I think given head and in, I think now this should work. Otherwise, this is the code because we just run everything here. The same code that I write here. Let's take another thing. Put it on head also. Let's see what happens. Because the code is okay. I don't know why the pseudocode is not running. No, it's not. So if you go to solution, it's simple as that. Same solution I am writing. I don't know why they are given. So actually their solution is this. Same solution. It is just advancing one loop. If you evaluate it, you can easily say it's okay. So our time is big of n, our space is big of 1. Okay, this is our code. This is the question. Go check out this platform. Use this link to get a 7-day free trial, and use this platform dsa.chaicode.com. Thank you very much.